Hi, good morning, everyone. I am Ankit Gangwal, and on behalf of my co-authors Shubham, Singh, and Abhijeet Srivastava, I'm going to present our work, AutoSpill, Zero-Effort Credential Stealing from Mobile Password Managers. This is a story about how good things can go bad. We live in the age of internet. We live in the age of the internet. There is a delay. Sorry for that. Which gives us access to information, variety of services, and possibly everything that we need in our day-to-day life. Apart from connecting the world seamlessly, it would not be wrong to say that it has become our world. Shopping, streaming, food delivery, taxi, everything is just one click away, right? We use a variety of devices to connect to the internet. We use our computers, which includes laptops and PCs and everything. And we also use mobile devices, such as your phones, your tablets. And in fact, mobile devices are becoming the go-to devices to connect to the internet today, right? If you want to check a quick information, you take out your phone and you check information through your phone. And also, if you look at the data, in 2023 alone, the market share of mobile devices, that is phones and tablets, was considerably higher than that of the computers, which includes your PCs and laptops. And it is also not surprising to see that the majority of the internet traffic generated worldwide comes from mobile devices. A similar trend has been seen recently and over the last few years, and it is only expected to grow exponentially, I would say. So, to summarize, whatever we have been doing on the computers, the common task that we have been doing on our computers has been now done through your mobile devices via your respective apps. While migrating from the computers to mobile devices, we have also ported one important task, and that task is your login. Because each mobile app is user-specific, it gives user-specific experience and features. So this is a very crucial task. And there are countless such apps that we use every day. And I do not even need to mention that the requirement each app has with respect to its credential. How many lowercase characters, uppercase characters, symbols, total length, and everything else. What does it do to us? It all contributes to increasing the cognitive load on the user. So you want to save a password for one app, another app, third app, fourth app, and thousands of apps. That's a problem for your brain, at least for mine. I cannot do a unique password, or even if I do unique password, I follow a pattern. So in general, what we do is we do use common passwords. 1, 2, 3, 4, 5, 6 is still the most popular password, right? Or we reuse the password. Whatever app you use, one password here, the same password somewhere else, the same password somewhere else as well. Or we use everything that makes the life of an hacker easier, right? And do I need to mention the consequences of a hacked password? The list is super long. Recently, we have been seeing something very, very, I would say, unpleasing, such as smart home break-ins, baby cam hacking, and all these things. We do not want that in our life. So in this scenario, who comes to save us? Our savior today is a password manager, and which is also the protagonist of this story, right? Another main character of this story is Android operating system, and both these characters are after this feature that we call login with third-party buttons. You can use your Facebook credential, you can use your Google credential to log in one app, right? Makes your life easier. Okay, quick background. We have password managers. What do? They help us store and managing your credential. They also help in choosing a stronger password when you are signing up. And most importantly, whenever we are signing in an application, they help us in auto-filling your credential. That's called autofill, or automatically filling the credentials. They are becoming increasingly common on computers. I think everybody here probably uses a password manager, one form or another, because of the convenience they offer, right? On mobile devices, the typing area is very small, where typing in your long password, secure password, could be time consuming and also a little bit difficult on your finger or your thumbs. So password managers are now becoming even more popular on the mobile devices because it's just, probably you see your phone or you do a fingerprint authorization and it fills in your credentials super fast. However, there is a difference between password managers implemented on computers and how they are implemented on mobile devices. On computers, they are generally implemented as a browser extension, which means this password manager need to do everything. From storing, from rendering, from prompting, from autofill, everything is done through your password manager and probably no or zero support from the operating system or the browser. In this scenario, the autofill ceremony includes just two parties. One is your website, which is waiting for the credential. Another is your password manager, and everything happens in between them. No interference from anybody else. But on mobile operating system, the requirements are different, the constraints are different. First of all, mobile operating system supports or advocates for system-wide autofill frameworks, which means they want autofill to happen on the browser as well as inside the application. Second thing is, mobile operating system, such as an Android system, has app sandboxing, which means applications are isolated from each other. They cannot talk to each other directly. So basically, in this kind of constraint, in this kind of scenario, we have autofill ceremony with at least three parties involved. One is your application that is waiting for your credentials. Second is your password manager that provides you the autofill services. And third is the Android, which intermediates all the information in between them. So application generates an autofill request, Android intercepts it, passes on to autofill service, and in the other way as well. Another thing in this story, another twist, is that we have web view controls that has been developed recently. They act as a minimalistic browser. Basically, when you click a link inside your application, the application can render the content in itself. So what is the benefit? You do not need to redirect the user to the main browser, which means it gives a seamless user experience to the user. I think you may have seen an option like this in your favorite or not so favorite mailing app, which tells you if you want to open a link or a page inside the application itself. How about seamless login using web view controls? So on your screen, what you see is a scenario where we are trying to log in into Microsoft OneDrive app, which supports third-party authentication. Here, we are trying to log in with our institute's email address, which is not Microsoft. So what this application will do is basically check the domain of the email that we have entered and fetch, if supported, it will fetch the authentication system this is for our institute. And then you can fill in your credentials or autofill your credential, whatever choice you take, and this will go forward. A similar thing happens from these buttons that we see here via login via Facebook or Google. You click on one of the options, and similar thing will happen in the background for you. Okay, after all this story, what is AutoSpill? If you have an application that is waiting for credentials, your username and password, and you invoke your password manager, which is written PM here, what you will see as a user, you will see a prompt. If you want to autofill, some of the options will be shown to you. You need to select one of the credential, like one of the username and password, and you need to authorize from whatever mechanism you have set, PIN, password, Face ID, or fingerprint. Once you authorize, autofill takes place. In this scenario, all your credential must be protected from all the application running in parallel. So there could be other application running in the background or in parallel or in split screen. In this case, you must protect your credential from all those applications. Now let's look at a scenario where you have an application. It has some element already, and it has now invoked a web view, just what I showed you before. So you have a web view. So this is a hosting app, HA, for your reference, and this is a hosted web page, HW. And in this web view, or in this page, we have username and password. In case I invoke a password manager here, nothing much will change. You will still have prompts. You will have the option to select one of the credential. You need to authorize still, and the autofill will take place. And we expect this autofill to happen inside these two fields, username and password field only. AutoSpill is a scenario that we found is when these username and password are spilled to hosting app, which is a violation of secure autofill process of the Android system, because this credential should have only went to HW and not to HA. This is a real-world credential autofill from Facebook page. So what you have on your screen is an application that we designed, which we call WebView test, and it has invoked a Facebook page. In a real world, this Facebook page will be full screen and you will not see this part at the bottom, right? So what happens in the background, you will not be able to see what's happening there, but just for your reference, we have shown a web view with a smaller screen space. When we try to autofill in this web page, which you see here, the credentials were auto-spilled to the base app, which is a gross violation of the secure autofill process. So this is the effect. I mean, this is what we are seeing and what we have seen so far. But the important part is, why does it happen? What are the factors behind autospill? So we need to investigate what are the real factors that enables autospill kind of behavior. To do so, we started with understanding the information exchanged during an autofill ceremony. And we created a custom autofill service, a custom password manager, just to intercept and identify the information. So when an application invokes password manager, your Android operating system intercepts this request and passes on the information to your password manager in the form of assist structure, which we will see in subsequent slide. We'll go into the details. And once the autofill service processes this assist structure and finds some matching credentials, it will give you suggestions in the form of data sets. Now, data set is a suggestion pair. In your application, for example, ABCD, whatever application, you may have multiple accounts. So you may have account 1, username, password, account 2, username, password, or you may have in the same application different people using the same application in the same phone or same tablet. So data sets come for all the credentials which are saved inside your password manager. It's not just one username, password. All this suggestion will come through this data sets which we have shown here. Okay, this is how your assist structure looks like. Just to be clear, the numbering that you see here, 1, 1.1, 1.1.1, are all done by us just to give you a hierarchical relationship among the elements that are shown here. So what you have here is, in this request, you have a root view, basically your application. In this application, you have native view, basically the hosting app. And then you have a web view, which was invoked when we wanted to log in via Facebook and all. And we also see there are 2 children of this web view. And the web domain is m.facebook.com. And the 2 children are username and password. What is also important to note here, that every field that you see on the screen has an autofill ID. But specifically, this autofill ID from where the request was generated and the autofill ID of the children are related, unlike the case here. Just to be highlighting this information, you see this information was, or this request of autofill was generated from this particular field. Android does its job and tells where the focus was. This was the focus ID, which means this request was generated from here, right? So this is the part that Android plays. The other part is when your password manager comes into the picture. Once it receives this assist structure, all the information, it needs to process this information in order to see if there is any credential which is saved or not. So what it does is that it starts, and with the help of the focus ID that I showed in the previous slide, it tries to find all the elements or all the input fields which could be a potential target for autofilling this request, right? In the first pass, we just identify the web domain that was, in our case, facebook.com. But your password manager tries to do even more so that it can give more convenience to the end user, because they want to make the life of the end user simplified. So they keep on searching into the assist structure, more potential target, and they try to fill in this autofill target list. Once all the assist structure has been parsed, they start to create data sets, and they pass it on to Android so that Android can show, it can give you a prompt, you can select and authorize, and autofill will take place. This is a standard process that happens, that we figured out how it happens. Now to summarize this investigation, this is all well and good, everything is documented, everything is fine. But what we notice here is that Android is going to render native view data, the native view, that is HA, even when the request was generated from the web view. Basically, what it is trying to do, it is trying to do more, and this doing more creates confusion for the password manager because you are parsing more or excess information, and that is going to create confusion for it. On the other side, what you see here is that your assist structure, your password manager, is going to parse everything that is given in the assist structure. It is going to take every information, try to find all the targets, try to give all the data sets for all the potential targets, and this is going to create a problem. Now, both Android and password managers are doing much more than what is required. Even though their intentions are good, even then, auto-spills happen. And this is the reason why I said in the beginning that sometimes good things can go bad. From this investigation, we do not blame that Android is responsible or password manager is responsible alone. We say both of them are responsible equally because both of them are doing more than what is required, and that is leading to a auto-spill scenario. Now, what is the biggest risk or biggest benefit of auto-spill if you want to exploit it as an attack? What you need to do, you do not need to rely on phishing anymore. You do not need to worry about tricking a web page, creating a similar web page and all. You just need to create a benign application. In this application, you will have input fields, username and password field, and you will also give the user an option to do login with whatever is supported. Then, if the user tries to do login with XYZ, a web page will be invoked in the web view, and if the user does autofill, you will receive credentials for free, just like what happened in AutoSpill. I'll show you a demo as well after this. But now, once this application receives these credentials for free, it just needs to process them. It can simply store locally and send it later over the internet or however they prefer. The worst thing is there is no malicious code involved. If you just receive some value and you save locally in your storage, it's not a malicious behavior. It's a normal behavior, which means such application can still live on official app stores where more and more users can be targeted. So this is why we said it's a very dangerous scenario, and we of course we officially and responsibly disclosed it before coming here. So in our evaluation of the real world scenario, what we did was we took top 10 password managers available on the Play Store. However, what you see here are just 7 password managers, and then you must be wondering what happened with the other 3. They were not suitable. They were not giving the desired result. That's not the case. The 2 password managers, they do not support autofill at all. So they just serve as a storage application. You can just securely store your credentials, but they will never support autofill. One of the other password managers, what it does, it treats application differently than your application and web page differently. So just to give you an example, com.facebook.katana, that is an application, will be treated differently as compared to m.facebook.com. Even though the user could be the same, I mean, you could be a same user using the same application and web page, but you are supposed to save your same credential twice. That's a problem because that's not seamless. So we excluded that in our evaluation. All these versions that you see here were up-to-date version as of August 2022. And the password manager approach they take are OpenYOLO and autofill framework. There is another one called LI service, A11I, but it's deprecated. So these are the 2 most famous approaches to do, most popular or the only 2 approaches available. To remove the bias of any device, any operating system, we took 3 different devices of 2 different types, 3 different Android versions, all of them updated to their latest security patch, and all of them were evaluated in our investigation. And one more thing, the Android system web view was updated to the latest version available. That was 103.0.5060.129. So we did 2 types of evaluation. One is when we made sure that there is no interference from the base app, which means we are not using JavaScript injection at all. So you have a plain application, just has input username and password field, invokes a web view, and autofill will happen there. And there is no interference, which means JavaScript is not enabled. And in our base app, the app which is calling the web view, we tried different combination. One is you have both username and password. One is when you only have username in the underlying app. One is the type of the field is password, and another case is when we did no specific input type. We said none. Just don't use any specific input type when you create the input field. So last pass, end pass, key pass to Android, and keeper. When two fields were present, AutoSpill both username and password. When only username was present, intuitively they only gave username to the base app. When password was present, password was given. When none was present, username was given. However, Google Smart Lock and Dashland were found to be safe in this scenario. They did not do any auto-spill behavior. And as far as one password is concerned, in this two scenario, it did not even prompt for autofill. It did not even come up when this was the case. However, when we created password field in the base app, it leaked password. And in case of none type, it leaked the username to the underlying app. Well, this is a very simple scenario when we are not using JavaScript injection, which is not going to happen in the real world. Because in a real world scenario, if you want to target users, you will use a JavaScript injection, which means your base app is going to do everything it can to capture the credentials from the user. When we use this thing, most of them, except for these two fields, they all were found to be vulnerable. And because we have JavaScript, we have more power to process information. We could not only just get username and password, but in fact, with just one field, we had the choice what we want to steal. We want to steal username, we want to steal password. And it was under our control what we want to steal from the user. Okay, a demo time. Let's do a demo. So the first thing is, what is autofill? Just in case, just for your reference, you say you have an account, you choose one of the option, the corresponding page pops up. You try to invoke your password manager by clicking, and once it prompts you, you need to select and you need to authorize, and autofill happens like that. Now, what is AutoSpill? So you have an application here that we created, which we saw before. So the user is going to open it. The user only see this option. There is only one option, open facebook.com in our case, but it could be also something else as well. Once the user clicks it, what happens is a web view is invoked. And what you see here is the Facebook page. And to demonstrate this attack, we are also showing the underlying app as well, which now has username and password field. When the user tries to invoke your password manager, whatever is your choice, you autofill there, you get username and password in the base app. This is a very dangerous scenario because this app has nothing to do with all these credentials. After we find this thing, we found that there are some little fix that the password managers are trying to do. So they fill in, for example, in this case, you fill in your domain, whatever is your email address, it checks, and it will try to load corresponding authentication page. You go on there, you try to invoke your password manager. When you invoke your password manager, it gives you a warning. Look, you want to fill an item that is from IIIT, and you want to fill in on OneDrive app. It's giving you a warning, and the ultimate decision is left with the user, which we believe is not the correct way to safeguard a common user, because they will just use the default setting, yes. Or even if you are tech friendly or if you are tech savvy, even in that case, it's not going to help in preventing auto spill, because once the user clicks on it, it will autofill, and underneath the application has already got the credentials. Okay, so what can we do to fix this behavior? So for your reference, I'm just showing on your screen the assist structure that I showed in one of the previous slide. So what Android should do is that it should not give access information. When the request is generated from the web view, it should only give information related to web view in the assist structure. It should not give any information relevant to native view, right? It's abundant, it's not required. Or if that is not possible, at least don't set web domain to null. Set it something which is valid, like a kill switch. You set some value so your password manager can identify, I should not target facebook.com on this particular view. As far as your password managers are concerned, they need to stop doing access processing. Because can you switch back to what's happening? Sorry for the interruption. Sometimes good things go bad. Okay. So what password managers should do is they should not do access processing. When they know that the request came from this particular field, they should only process this part and do not try to process more than what is required. So for testing this countermeasures that we proposed, what we did a quasi simulation because one, the the source code of the password managers is not available, so we cannot play there. Second is rebuilding an Android operating system code for a specific target device involves specific and proprietary softwares, so we did not want to go that way. So what we simply did, we used the autofill ID from the assist structure itself and only processed this information to identify the target and supplied back information only for this specific target, and we did not find any of the autospill happening in the scenario. Okay, what can we learn from this talk? Password managers, they work under different constraints, specifically Android's app sandboxing, where Android intermediates the autofill process. Your Android operating system gives access information, and your password managers, they do access processing, which leads to autospill behavior. And it is a serious problem because in autospill, you do not need phishing to be done. You do not have any malicious code inside the application. So it's a serious scenario. To fix this, both Android and password manager developers should come together and try to fix this problem. I would quickly like to give image credits that I have used in this slide. I thank you all for your attention, and I would be happy to answer any question that you might have. Thank you so much. Sure. There's a mic there, or if you just ask me, I'll repeat the question.
I wanted to ask if there is a way for a hacker to do some kind of like checking for all the passwords that are inside the password manager. So you can like make the loop for the request or something to get all the passwords out of it? Or is it just like targeted for the one that the autofill is doing in this particular moment? So is there like a broader attack spectrum possible with this?
Thank you so much. That's a very nice question. I'll just repeat it. So the question is, if it is possible for an attacker to traverse through all the repository that your password manager has, all the password and credentials, and choose one of them. In our specific investigation, we wanted to do the same. We wanted to target that. I want to choose your username and password, but that is not possible because after the processing by the password manager, only data sets comes to Android system. So only specific information comes. And in this scenario, it's not possible, fortunately, for the attacker to choose and pick in this case. Thank you.
On iOS, you also have applications and web views. Does it work similarly? Like, is this attack only on Android, or is it also on other devices?
Thank you for the question. So the question is, if this attack will work also on iOS devices, which also has web view and all. We are doing some investigation into this particular domain. So we started with Android because my students were very good at Android, and by the time we come up to these results, they graduated. So it's still on the plate, and we are trying to prevent this kind of behavior there, and we are doing the investigation. So at the moment, I cannot say for sure if it's possible or not, but there is a possibility. You might have to take a different route, but who knows what's behind. Thank you.
Hi, my question is, could you report these issues to the bug bounty programs of the associated?
Sorry, I cannot get.
Could you report the issue to the bug bounty programs of the password managers?
Yes.
And if so, how did they respond? Like, how did you rate
Very good. It's a very good part of the story. So in May 2022, we found this thing. We reported immediately to Android and all the password managers. Android and their security team took some time, did their investigation, acknowledged this, it's a valid problem. They gave this issue a severity 2, a priority 2 issue, and they tried to fix it. On the other side, for the password manager, the story is completely mixed up. Some password manager quickly acknowledged this thing, and they said they promised they will fix it. Some of them did not even respond to our emails. We tried to follow up. I don't want to name anyone, but we tried to follow up. Look, there is a serious problem. No response at all. However, there was another category that came after us and said, this is not a problem for us. This is a problem with Android. That's what I said in the presentation as well, that when this behavior happens, they try to blame each other. And this was the case specifically when we even tried to give them a white paper. We even tried to give them all the details, demos, codes. They were not ready to accept that there is a problem in their password manager. So unfortunately, that was the case. And I think we did what we could do.
So only Android, only Google fixed the issue?
Sorry?
Only Android fixed it?
So they said they will fix it.
But didn't.
I cannot comment on what they did afterwards because let's not.
So it's still live? Like it's still reproducible?
So what we could find that there are some fixes, but we still can do more than what we could do before. In fact, what we can do is a reverse autospill as well. I mean, we are trying to do reverse autospill as well. Instead of stealing stealing through underlying app, can we do something reverse direction? We are investigating that part. We do not have the concrete results yet, but we are working towards this direction. Because that's a very serious scenario. You have ad banners running in your application. That's like a third-party controlled information. If there is something possible, that would happen. Then you select and choose. That's what we are trying to investigate. We don't have the results yet, to be very honest. I don't want to say we have results, but we are investigating. Thank you.
Is there any way for the Play Store to detect this kind of malicious application?
Good question. So the question is, can Play Store, where the applications are hosted or from where it is distributed as a trusted source, can do something about it? So they have a bouncer which checks on for the malicious code, what you can do. What we found that the base layer, the base application is only saving some credentials. They are just receiving some information. They have the right to copy and paste and save and store and do everything. It's a normal behavior. So within an application that is doing everything normal according to the norms, I don't think there is a syntactical or semantical way to identify this thing. At least we are not aware of it. But we hope that there is a way to fix this kind of issues. Because then the application is coming from a trusted source. Everybody is trusting the application, the password manager, and still the problem exists with the autospill. Thank you.
I had like one more question or like one idea. Maybe you can shine some light on it. Like, let's assume you're the attacker and you're making the app where you still try like to query all the passwords from the password manager, and you would have not one web view but two. Like you try to use the JavaScript to query through all of them in the background with a like hidden web view, which just like gives multiple application queries in the same time, while the original web view is like just displaying like, let's say, the Facebook login or whatsoever. Would this be possible, or is there like any Android or password manager function that will intercept this kind of attempt?
Good question. So the question is, what happens when we run two web views instead of one and try to switch back and forth? So exactly what we did also to what you just mentioned. I mean, we followed the same line. So we tried to do two web views, three web views, multiple web views running in parallel. But what we found that it's not successful. When you have one web view in focus, only then it works. So you must be in focus for all this process to work, which is a common thing that happens in general, right? So with 2 or 3, it did not help. I hope somebody else can find something, or we can find something, so we can report again and come back. Thank you. So if not any more questions, thank you all again for being here.